Okay, children, welcome to this video on rate of reaction. In this experiment, we will be studying the effect of concentration on the rate of reaction. If you look in your syllabus, you will see that this has been given under topic number 2, where it says study of the rate of reaction. The candidates will be required having been given full instructions to carry out an experiment on the rate of reaction, for example, sulfate and hydrochloric acid for either using different concentrations. So today, what I'm going to explain and the video that you are going to see is between a magnesium strip and the dilute HCl solution that we have taken, whose concentration is going to be varied. What all you will need is a graph for where you will be plotting the volume of the undiluted acid versus the time. These are the two things that we have to do and its interpretation. Now in this experiment, you will be given HCl of the known strength, all right? And then what you have to do is actually, you will have to take the 25 ml of that HCl solution in a beaker. So this is a beaker in which you are going to take the 25 ml of a provided solution of HCl. Let us say it is a 2 molar solution of HCl. All right. So this is obviously kept in a conical flask or in a container. From this, you are going to measure out in a cylinder. You can measure out, measuring cylinder. You will measure out 25 ml of the acid and pour it into this beaker. Now this beaker is containing 25 ml of HCl, in which you are going to add a strip of magnesium ribbon. Now how will you get the magnesium ribbon? A magnesium ribbon is the roll is taken, and from that 3 strips of the same size are cut. You try to have the strip length almost the same size. The thickness will be the same because it is the roll of magnesium and the pieces are from the same strip. So if you take 3 strips of the same length and keep them ready, then we are ready with the experiment. Now what you do is, in the first instant, the first experiment or the first reading, what you will do is, you will take 25 ml of the acid in the beaker, and to this you will add a strip of magnesium ribbon. As soon as you add a strip of magnesium ribbon, you will start noting the time on the stopwatch. Since magnesium is above hydrogen in the activity series, a reaction between magnesium and HCl will start, and what you will get is actually magnesium chloride and hydrogen will be liberated. All right. Now, since hydrogen is being liberated, you can see the effervescence, the bubbles rising, and the magnesium ribbon is on the surface. It is moving around. As soon as the magnesium ribbon is added to the HCl, you start noting the time on the stopwatch. Now, as you will see that the magnesium strip is slowly disappearing. Now, when it slowly disappears, what you do is you keep watching, and a time will come when the bubbles also will stop rising, and it is an indication that all the magnesium ribbon has been used up. You note the time. This is the first experiment that you have carried out with the undiluted acid that was provided to you. And the time is noted. I will show you how to prepare the table afterwards to note down the timings. Now, in the next experiment, what you will do is, now you can throw the solution from this beaker and get ready for taking the next reading. For the next reading, what you will do is, I will just erase this out and show you. For the next reading, what you will do is, you will take the same beaker, all right? And in the same beaker, you will now take 20 ml of 20 ml of undiluted acid. Which acid? The one which has been provided to you. So you will take 20 ml of undiluted acid, and to this you will add 5 ml of distilled water. 5 ml of distilled water. Now, when I do this, what have I done? I have actually diluted the solution, and the concentration of HCl solution has been changed. However, the volume of the solution that I'm taking remains the same, that is 25 ml. So in the same beaker, you are filling the beaker with 25 ml. Obviously, the amount of solution, the height of the solution will also be the same. And to this, the second magnesium strip of the same length is added to the beaker again. As soon as you add the strip to the beaker, you start noting the time. All right. Now, what is expected? It is expected that in this case, since the solution is diluted, obviously what will happen? The time taken for the magnesium strip to disappear completely will be more. Now, in the first experiment, the time, let us say, you will see in the video that we have prepared actually in the lab for this experiment, you will see it took us 2 minutes and 7 or I think 6 or 7 seconds. Let's go with 6 seconds. All right. For the magnesium ribbon to be completely used up. In the second experiment, this is the first timing that I got. For the second experiment, again, when it was carried out this way, the timings that were seen in this case was 2 minutes and 40 seconds. It came to 2 minutes and 40 seconds. All right. Now, again, what you do is, again, you will throw the solution that is there in the beaker. Throw the solution. Again, you get ready for the third experiment. In the third, this was second number. Now in the third experiment, again, after you have washed the apparatus and you are getting ready, again you will take the same beaker. In that same beaker, now you will add 25 ml of the solution again, but this time you will take 15 ml of undiluted acid, okay. And what do I mean by saying undiluted acid? It is the acid which has been provided. Plus, you will take 10 ml of distilled water. Why will I take 10 ml of distilled water? Because we don't want any other impurities to be present. So we are taking distilled water. All right. Here also I will write acid. Here also I will write water. Now this again makes it 25 ml. All right, so a total amount of solution is 25 ml. Again, this is added in the beaker. A magnesium strip is added to the solution. As soon as the magnesium strip is added, you start the stopwatch and you again start noting the time. In this case, in the third experiment, you will see that the time that was actually taken for the magnesium strip to completely disappear was actually 3 minutes and 7 seconds. So it was 3 minutes and 7 seconds. Now this is what we did in the lab. And if I do that experiment, all right, in another beaker, maybe the time will vary. If I take a narrower beaker, the height of the solution will be more. If I take a flat beaker, the amount of solution that is there will be, kind of little flat. So actually what we need to do is the amount of solution that we are taking should be the same. And though it is not very necessary in this case, but actually you need to use the same beaker in all the 3 experiments, especially when you are doing the experiment with sodium thiosulfate and HCl, where the turbidity is seen to appear, and the setup is such that you have to watch that as the turbidity appears, a cross which is placed under the beaker is actually disappearing. So if the time permits and if things go all right, then maybe we will be able to show you that experiment also. But right now we are only doing the magnesium ribbon. The strip of magnesium ribbon is added to HCl and the time is to be noted for the magnesium strip to be used up. Now you see in this case, the 3 timings I have noted: 2 minutes and 6 seconds, 2 minutes and 40 seconds, 3 minutes and 7 seconds. Now for the next step that you have to do is, you have to tabulate the, prepare a table for this. And how will you prepare a table? That I will show you. Let me clear this out first. Now you will draw columns like this, all right? You can draw columns and you have to take 3 readings, so it should be fine. So you take this like this and another one here, and you write experiment number 1, experiment number 2, experiment number 3. Then here you will write volume of undiluted acid, volume of undiluted acid. That is the acid that has been provided to you. By undiluted, we don't mean, going and getting the concentrated solution from the market. Okay, it just means that it is the solution that has been provided. And suppose if this is the volume for the undiluted acid, then here the second column should include amount of water added, amount of water added, distilled water added. This is what will go here. So undiluted acid in the first case is 25 ml. All right. Amount of distilled water added is 0 ml. All right. In second case, it is 20 ml. And the amount of distilled water added is 5 ml. In the third case, it is 15 ml. And the amount of distilled water added is 10 ml. So this is distilled water and this is the acid column actually. So this is what it means. Okay. Total amount of solution will remain the same. And here you can write down time taken. This will be T, time taken for the magnesium strip to disappear. All right. Time taken for the magnesium strip to disappear. Now, in the first case, it was how much? 2 minutes. And now if you are writing this in seconds, you will have to convert that into seconds. So we will do it both ways. So I will take it in minutes here first, and then we will convert into seconds. Okay. So let me see. The minutes is 2 minutes and 7 seconds. 2 minutes and 7 seconds. All right. So this comes to 127 seconds. 127 seconds. Okay. In the second case, it was 2 minutes and 40 seconds. 40 seconds. So the total seconds that it will come to in this case will be 160 seconds. 160 seconds. And the third one, it is coming to 3 minutes and 7 seconds, which makes it 187 seconds. 3 into 6 is 180, so 180, and that makes it 187 seconds. So this is your observation table, you can say, or this is the tabulation of the timings that were taken. All right, this is the minutes, the actual time you are taking in minutes, and here it is taken in seconds. It will depend on which value of time you will take for plotting the graph. Okay, because we have to plot the graph also. Now this is about it. In certain books you will see 100 by the seconds taken is this is how it is divided. 100 by 127, and whatever the values are, that is used for plotting the graph. But we will only just proceed with these two. So this you remember and see how it has to be written. Now what is the next step? Once this has been done, you will be required to plot a graph. All right. Plot a graph for what? You will have to plot a graph for volume of the undiluted acid against the time taken. All right. So I have a slide with me for the graph, and we'll try to see if I can, draw that for you. So this is about the, okay, this is the graph I have with me in the, yeah. Now you see in this case, I'll put this thing up here. Okay. All right. So we will draw the graph. What you can do is, if I am taking this as the axis, so I will, just went a little wrong. I'll just do correct this first. Okay, so you will take this axis, again it is going upwards. You will take this axis for the time, okay, and this axis for the undiluted acid. All right, let this be 0 and you can put a break mark here. So now we will plot, we'll try to plot the graph and see what will be the nature of curve, because we have to interpret the rate of reaction from this. So I will start, let this be 130. Okay, let this be 130 seconds because my least reading is 130. So I will make it as 130. Then let this be 140. Then I will make this as 150. Let this be 150. Then I can take this as 160. Let this be as 170. All right. And then of course this one will be 180. This is 180 and this is 190. This is 190. All right. This is in seconds. I am going to plot the graph. All right. Now, if you look at the undiluted acid, this is the volume of the undiluted acid. Volume of undiluted acid that you have taken. Okay. So in this case, obviously, I can start with let this be 10 ml, or because we are not using 10 anywhere, let me start with this as 15. All right. Let this be 20 ml. All right. 20 ml. And let this be, after one I'm making, let this be 25 ml. 25, is it not writing? So I'm going to make this as 25 ml. All right. So this is the kind of graph you will have to draw. So this is 25 ml. All right. This is 20 ml. Now, let us plot what we have done so far. In the first reading, we are taking it as 120. But seconds, in seconds, what was 130. I'm presuming that maybe, you know, because the in between, if this is, that means I started from 120. So I can take this as to be the 60, that is 126 will be somewhere here. Okay. Now for 20 ml of the undiluted acid, again I have to mark. So for 20 ml, it is 2 minutes and 40 seconds. So that means it is going to come to 160 seconds. So here, this is 160 and this is 20. So this is the point I will get. This is the point I will get. And for 15 ml, it is coming to 187 seconds. So for 15 ml, it is going to come somewhere here. Okay. 90. So if this is 80, so 2, 4, 6, and 7. Okay, let it be here. All right. Now, if when you draw the graph for this, you will actually see in this case, all right, if I draw, okay, the hand is not very stable, so it is coming to be like this, it is shaking. All right, so this is when you draw the curve like this, you can see that it is not a very straight line as such, and maybe, you know, this reading that is at 160 that I'm getting here could be a little less than that maybe. Anyway, because I took the reading a little on an approximate value. So this is the kind of graph you will get. So what you understand from here is, what is the inference of the graph? That as the concentration of the HCl solution is decreasing, all right, the time taken for the same magnesium ribbon to disappear is increasing. All right. From this, you can also find out the rate of reaction. Children, one more thing I'd like to point out here. This graph that I have drawn here with the stylus hasn't come out very sharp. You know, you have to use a sharp, a pencil with a very sharp point to draw the curve so that the lines are very fine. Okay, now here this has come a little shaky and, you know, kind of little disturbed, but anyway. if you are required to find out the rate of a reaction at any instant of time, then how will you do? In your chemical kinetics you have studied, what you can do is, let us say I want to find out the rate of reaction when the time is about, let us say 140 seconds. So what I can do is I can draw a tangent here, okay, extend it equally on both sides, then you will drop a perpendicular here, drop a line like this, and by the amount of the acid that you are getting here, or if this graph, this axis is representing the amount of any reactant used up, then you can use the dx by dt formula to find the rate of the reaction at that instant of time. Since in this graph you will see that it is only the volume of undiluted acid, we are not going in to find out the rate of reaction in this graph, okay. But we will try to do one thing here that is there in your question also. I have given that how much time will it take for the same size magnesium strip to dissolve in 18 centimeter cube of the same acid. So if this is 15 and this is 20, then you can imagine that this is 16, this is 17, this is 18, and this could be somewhere around 18 here. So if I'm taking this to be 18, and then I will have to drop a perpendicular like this, okay, perpendicular like this, and it is meeting the graph here. From here, you will drop a perpendicular to find out the time taken for the magnesium strip to disappear when you are taking 18 ml of the undiluted acid. So for various concentrations, you can get the values. Now remember, it is not necessary that all the children will get the same values, okay. It may depend, because sometimes the size of the magnesium strip may be little varying, all right. Sometimes when you are diluting it, you are not very precise with adding the water. So sometimes that a little amount of water may be added more, or sometimes the solution may be a little bit more concentrated. So thereby, it is not necessary that all the children who are doing that experiment get the same value. But yes, a proc have to do, that is plot a graph for the volume of undiluted acid versus the time taken for the magnesium strip to completely disappear, okay. Now this is a part of the question, and the next thing that you have to do in this case is, I will show you that. I'll remove this now, remove the graph, okay. The next thing that you have to do in this case is the questions you have to answer related to the experiment that you have done, okay. So let me see now. I have to go to that slide, okay. You see, these are the two questions you will answer after you have plotted the graph, all right. Inference can you draw from the graph obtained, and how much time will it take for the same size magnesium strip to dissolve in 18 centimeter cube of the same acid, HCl. Here the same acid means the acid that has been provided, all right, the acid that is provided. So in this case, I can write here acid that has been provided in the laboratory for the experiment to be conducted. Once again, if you want, I will just show you how to draw the table, and that's all. And these two questions will have to be answered. So let me just draw the table once again and show you how you are going to do that. Okay, let me clear this. All right. So the table is going to be like, I don't know from where this started. Okay. All right. So you will have a line like a column. Though I have already done it, I'm just doing it because that did not come out very clear. And so this is going to be experiment number column, and this is going to be the acid and use. So this is experiment number 1, experiment number 2, experiment number 3. So this is for experiment number. All right. Here then you will have volume of undiluted acid. This column will have volume. Now see, you will be able to write it better because my stylus is not helping me to write small alphabets. Volume of undiluted acid. So this is going to be volume of undiluted acid. Undiluted acid. Okay. In some books you will find that the amount of water added is not mentioned at all, but we will write both. So this is 25 ml, this is 20 ml, and this is 15 ml. All right, you can write the units here, or you can write the units in the header or the column here. Here you will write volume of distilled water added. Volume of water added, distilled water added. Please write it in full words. I'm just writing it in short. This is going to be 0 ml. This is going to be 5 ml. And this is going to be 10 ml. So that in each case, the solution will become equal to 25 ml. Here you will write time in seconds. Time in seconds. All right. So when I'm writing time in seconds for magnesium strip to disappear, here you can write down in minutes and then convert that into time. Because suppose in the first case I got 2 minutes and 6 seconds. All right. So this I can write it as equal to 126 seconds. All right. So both the things you can write, or you can just write the seconds straight away, no problem. In this case, it was 2 minutes and 2 minutes and 40 seconds. All right. And so this was equal to 160 seconds. And in the third case, it was coming to 3 minutes. All right. And 7 seconds, which was equal to 187 seconds. 187 seconds. So you can prepare your practical copies by writing these values only. In your experiment in the copy, you can write using the same value. This is your video for explaining the theory behind the rate of reaction. So what are the factors that govern the rate of reaction? Factors that govern the rate of reaction are temperature, particle size. Then you also have the concentration. Now in this case, we have studied the effect of concentration on the rate of reaction. All right. So if the time permits, we will be doing more experiments based on this. So this is all for now. All right. So I'm going to clear this. So I hope you had a good look. I'm going to clear this and let's go back to the slide that I have. So these are the questions you will answer in the copy. And one more thing you must note, that a graph of volume of undiluted acid versus volume of undiluted acid versus the time in seconds should be attached. Okay. Time in seconds you will take. All right. So this time in seconds you will have to do. You can take x-axis and the y-axis accordingly and plot the graph. The inference that you are going to take here is going to be from the graph that you are seeing, or from the graph that you will be plotting the results, or what is your inference that you can draw from the graph that you will write. So what will be the inference? That the rate of reaction actually decreases with the decrease in concentration. The time taken for the magnesium strip in the subsequent experiments, as the concentration of HCl is diluted, becomes more and more. So either one of these sentences you can write to answer the question number 1. And of course, this second question you will have to find out from the graph. I have already shown how to do it. So from the graph on the x-axis, you will look for the 18 centimeter cube measurement or the point on the graph, and then you will extend it towards the curve that you have obtained, and from there you will drop a perpendicular on the time axis to find out how much time it will take for the magnesium strip to disappear. So this is all about it, children. Thank you for being there and connecting, and it's a request that all of you must watch the video that they are uploading, and it will be nice if all of you can go and like the video so that your friends there is marked how many of you are um, checking out the videos that are being uploaded on the school website. That also can be checked there. So that's all. Please definitely see the video for titration. Sorry, this is for rate of reaction. The video that will be uploaded along with this to see how Sir Thakur is demonstrating in that video, how the experiment is being carried out in the laboratory. So thank you, children.